We are now looking at 60.3. I can compare objects in the real world by calculating the volume. So my first example, Marge has a cylindrical tin of popcorn that is 18 inches tall and has a radius of 4 inches. She wants to use the tin for something else and needs to empty the popcorn into a box. The box is 8 inches long, 8 inches wide, and 14 inches tall. Will the popcorn fit in the box? Explain. Okay, so I have this cylindrical tin of popcorn. I want to know how much popcorn do I have? Okay, so I have a tin. The cylinder, so I'm going to draw my circle, my height, my circle. My beautiful cylinder here. It's 18 inches tall and has a radius of 4 inches. So I'm going to find the volume of this cylinder. So again, for a cylinder, volume equals pi r squared, because it's a circle, times the height. Okay, there's no point, so there's no 1/3 in this one. And that equals pi, my radius, right, was 4, times my height is 18. Okay, so 4 squared times 18 is 288. Pi, this is inches cubed. Okay. I need to know, is the box going to hold that much popcorn? So then I have this box. Box. Beautiful. 8 inches long, 8 inches wide, 14 inches tall. Okay? So my volume of the box, again, volume for a box is length times width times height. So I have 8 times 8 times 14. These should all be in inches. And then 8 times 8 times 14 is 896. Okay. So I want to compare these two numbers. The only issue is this one has a pi in it. My other one doesn't. So when comparing real world numbers, okay, I need to get rid of the pi. So all I'm going to do is I'm going to do 288 times pi. And I get 904.77 inches cubed. Okay. So just be careful with those pi's. Remember, on the TI Inspire, the pi is right next to the letter H on the bottom. Okay. So now, which one of these holds more popcorn? Well, my cylinder holds 904 inches cubed of popcorn. My box only holds 896. It's just short of being big enough. So, no. The popcorn will not fit into the box. Because the tin, I don't know why I put a comma there. That's fine. Because the tin is bigger. So this is all the volume stuff has a lot of real world application. Because let's say you're moving, even if you're doing this exact same situation, before you dump popcorn all over the floor or get a box dirty that, you can say it right. I know it's not going to fit in there, so I may as well go look for a bigger box. So I don't get a box dirty that I don't need to have dirty, whatever. Okay, so volume really does help out with a lot of those things. All right, let's look at example number 2. A number 10 can, the one with the number 10 on it, has a diameter of 6 centimeters. Okay, so I'm going to draw that in. It has a diameter of 6 centimeters. So remember, diameter is all the way across. And a height of 17 centimeters. The other can has a diameter of 8 centimeters. These are obviously not to scale. And a height of 11 centimeters. Okay. Cans are not to scale, right? Because it doesn't really make sense. If the cans are the same price, which one has a better value? So let's say these are cans of tomatoes, I don't know, whatever you like to eat. That's what's in this can. Okay, I want to know which one do I want to buy. Okay, they're the same exact price. So I'm going to find the volume of both of these to see which one's going to give me more. Okay, so let's start with the number 2.5 can. So again, volume equals, there's no point here, so it's just pi r squared times height, which equals pi times, hold on, my diameter is 8 centimeters. I need to find my radius, which is going to be 4 centimeters. Okay, so be careful with that. And then my height is 11. Okay. So pi times 4 squared times 11. I get 106. Sorry, that was 176. Forgot my number. 176 pi centimeters cubed. Okay, now let's see what the number 10 can is. So volume equals pi r squared times height equals pi times, again, what's our radius here? Well, my diameter is 6 centimeters, so my radius is 6 over 2. Right, half of that is 3. So then that's 3 squared times 17. So, oops. So that's 3 squared times 17. And I get 153 pi. So looking at these numbers, one's 176 pi and one's 153 pi. So the number 2.5 can is a better value because there is more in it. Or whatever. We don't know what's in these cans. Okay, but 176 is definitely bigger than 153. All right, let's look at our last example for these ones. Okay, you are at the grocery store. You try to decide which box of tissues you should buy. The measurements of each box and the price are given below. Decide which box is the best value. So I'm going to start with finding my volume of each of them. How much am I going to get in each of these boxes? So again, volume equals length times width times height. Here I have 20, 10, and 10. For this one, I get 2,000 centimeters cubed space for my tissues. Looking at my second box, volume equals length times width times height. I get 10 times 10 times 10. I get 1,000 centimeters cubed. For my last box, volume equals 25 times 10 times 10, right? Which is 2,500 centimeters cubed. Okay. So that just tells us how much volume. Here, though, not all of my boxes are the same cost. So I can't just decide that they're all the same. So to find what we call our unit value, our unit value equals the price divided by the amount. And in this case, our amount is going to be the volume. How much am I going to pay per centimeter cubed? Okay, puts it all into one type of unit, basically. Okay, so for this one, our unit value is going to be, our price is $3.55 divided by 2,000, which equals 0.00, I'll even round it, 1/8. And it's price, so that's dollars per our centimeter cubed. So I'm paying 0.18 cents, right, less than a cent, for each centimeter cubed for that one. For here, right, our unit value is again price over amount, which is going to equal $2.45 over 1,000. And we get 0.002, we'll round up to 5. That's dollars per centimeter cubed. Okay. So right now, this one's winning, right? This one's only 0.18 cents per centimeter cubed. I have to pay a whole 0.25 cents for each centimeter cube for this box, which makes sense. If you've ever been grocery shopping, usually the more you buy of something, the bigger the package, the less per it's going to be. It's more expensive overall, right? This one's definitely more expensive than this one, but I'm going to use a lot of it. It's cheaper to buy it in bulk, as they say. So let's look at our last one. The price for the amount, which equals, so I have 3.85 over, I have 2,500 of these. 3.85 divided by 2,500, 0.0014. Is it 145? 1.5. 0.15. Okay? Per centimeter cubed. Okay? So, which box is the best value? Even though this one costs the most, it's also the best value. I'll scroll down. Because it is cheapest per centimeter cubed of tissues that you want. Okay? Alright, that is it. Go ahead and work on D3.